No. It's not E, my god. No, it's incorrect. We're gonna change it later, right? Oh no. See. Right. Oh. Oh. Die. My god. Yes, yes. And not entertainment. Education. Yes, education. Yes, and this one here. 36. Soon to YouTube. Yes, and we have to go to Zoom, right? Because maybe I have to try to find from 60. So now plus magnetism to iPad. Yes. To Suankularb magnetism. Sem. Yes, and we return to this one. Empty. And go to this here. Suankularb plus magnetism, electricity. This one. M604 today is 10.06. Okay. Yep. And anything else for M605? 38. Yes. 605. 10.06.2022. All right. Okay, test 1 2 3 เสียงไปนะครับ Okay, test. All right. Okay. Good morning, everyone. Welcome you to SCI33205. This is the section for M604. Where is that? All right. Yes, everything is fine. We're gonna start our lecture soon. For M604, we arrive at this one, right? The charged particle, right? That is moved. Oh, I forget to share the screen in Zoom, right? My God. Share screen. All right. ก็มีคนเริ่มพิมพ์ชื่อมาครับก็ตามนั้นครับตามข้อตกลงเราครับมีเดวิดนะครับอัครนันท์มาครับมาเรื่อยๆครับจนถึงประเทศครับ What else? Yes, right here we arrive at the charged particle that moves through magnetic field in a magnetic force, right? On page 14. But let's move to the newer version because I have updated something. 14, right? Okay, right here. Yes, we need to use the right hand rule, right? In order to we need to use the right hand in order to find the force direction, right? And you got to know last time the cross product, right? Because cross product is important to this one. You start your finger from your four fingers from vector v, right, to vector b, and after that your thumb direction will point to the direction of the force. Okay, and the whole process here that you use your hand, your four fingers, is known as the cross product. Okay, and we will talk about the magnitude of the cross product later. Okay, by taking the absolute value. All right. Yes. Let's get to know this person. His name is Hendrik Anton Lawlens. Okay, he was a Dutch physicist and he's famous. Okay, he shared the Nobel Prize in Physics in 1902 or 1902. With Peter Sem. Okay, you will know something about Sem later in chapter 6, I think. Okay, you will get to know Sem effect in chapter 6. And he and Peter Sem were awarded by the Nobel Prize in Physics for discovering and explaining the Sem effects. And yeah, for us, he is important because the whole thing, the whole process in order to find the induced force here is due to this person, Lawlens Force. Okay, and the force here is known as Lawlens Force. Okay, due to this person, and it can be computed by okay, it's taken from reference number 4. Can be computed by this formula. Okay, as I told you, you start your 4 fingers from the vector v to the second vector, which is vector b, and you got to know the idea of cross product already that I have mentioned it here, right? The cross product, yeah, it's a cross b and so on, right? Yeah, and yes, the result will be vector quantity, as you know here. It depends on unit vector I, unit vector j, unit vector k. Sometimes once the quantity in vector k is 0, so it's no problem. We don't have the component in the z axis. And yeah, in details, q is the charge quantity. Okay, if q is a positive charge, okay, if q is a positive charge like this, okay, your time direction will be in this way. But if your q, your charge is negative, it means that your F here, your force here will be will point in the opposite direction to the former one, to the positive one. It means you, instead of pointing in this way, the force will go to the opposite way. Okay, like this. Yeah, that's the force due to the negative charge. Okay, here we have negative charge, and yeah, that's the F equal to q, and v cross b will be the vector. Okay, v is the velocity vector of the charged particle in meter per second, and q will be measured in coulomb, right? And the x sign or the cross multiplication sign here means the cross product operator between 2 vectors. In the last quantity, the b vector is the magnetic flux density. It's measured in Weber per square meter. It's Tesla per no, it's Tesla. Okay, yeah, you know the vector version of the Lawlens Force due to this person. And after that, we are gonna find the magnitude, right? For us, actually, this formula is valid for bachelor degree, but I don't mind. Okay, I have already given the background to you about the cross product and the vector in 3-dimensional system, right? If you start the first year in bachelor degree, you're gonna meet this 3-dimensional coordinate again. But right now, you got to know already. Okay. Now we will talk about the magnitude. Okay, magnitude, of course, is the absolute value, right? We need to, you know, this operator, right, which is the magnitude operator. Okay, let me mention it to you again. For example, if you have absolute value of number 1 minus number 1, right, it's gonna be 1, right? And absolute value of 5 will be 5, right? It's something like that. Absolute value of I minus 2j plus 3k, somehow it's going to be a square root of 1 square plus 2. Oh, sorry. It should be minus 2 square and plus 3 square. All right, and it turns out to be square root of 14. I think, yes. Yeah, somehow like that. That's the absolute value, right? You got to know this. And yeah, we will take the absolute value operator onto the force in terms of vector expression here in equation number 1. And of course, the absolute value will embrace all whole term here, the whole expression there. And here we have the absolute value. Okay, that covers every variable, these three variables, and because this is the product between two things, right? The chart, which is the scalar, this is the scalar quantity, this is the vector value, and the absolute value will cover the the chart, okay, which is the constant, okay, which is a scalar, and the absolute value operator will also cover the second part, which is the cross product result. And as you know, the cross product result is a vector quantity right here, right? We get somehow like this for M604. Yes, the absolute value will cover the cross product, and from the theory of vector cross product, it turns out to be the absolute value of the first vector, okay, vector v, and the absolute value of the second vector b. And one more term, sinusoidal function of the angle, or angle of what? Theta is the angle between vector v and vector b. All right, and let's say we have v, okay, that is without the vector on top, okay, it's the magnitude version, and let's say the letter b without the arrow on top as the absolute value of the magnetic flux density vector. All right, without the arrow will be the scalar. Anything that has no arrow will be the scalar version. All right, theta is the angle between v and b. All right, it's not too difficult, right? This expression, the unit is important for us in physics, right? F is Newton, and v is measured in meter per second, right? In the typical way for the physics, okay, SI system. The flux density will be measured in Tesla as same as the vector b, and theta is the angle which can be in either degree or in degree or radians, okay. ก็ภาษาไทยนิดนึงแล้วกันครับเพื่อให้คุณได้กระจ่างครับก็เราเรียนกันเรื่องการหาแรงนะครับที่เหนี่ยวนำนะครับเกิดจากขออภัยนะครับสำหรับคนที่รอคอยภาษาอังกฤษผมเอาให้คนไทยนิดนึงนะเดี๋ยวเผื่อว่ามันสำคัญนะครับตรงนี้จะเริ่มต้นของบทจะพาหาแรงกันทั้งนั้นนะครับก็เป็นประจุที่วิ่งไปด้วยสปีดความเร็ว v นะครับวิ่งผ่านสนามแม่เหล็ก b นะครับแล้วก็เราก็ม้วนมือนะครับจากมือ4นิ้วของเรานะครับมือขวานะใช้มือขวานะครับหมุนไปนะครับ v ไป b นะครับอยู่ที่ห้องจริงผมก็เคยพาคุณม้วนมือมั้งนะครับหมุนไปนะครับม้วน4นิ้วไปธรรมชาตินะครับคุณไม่ต้องลำไทยดัดไปข้างหลังนะครับโอเคไหมแล้วนิ้วโป้งก็จะชี้แรง F ของคุณนะครับไม่รู้ว่าผมมีรูปอันนั้นหรือเปล่านะอยู่ในหนังสือนะครับน่าจะมีนะโอเคจริงมือขวาม้วนมือก็ได้นะง่ายสุดนะครับหรือว่าจะใช้3นิ้วก็ได้3นิ้วมันเดี๋ยวผมหารูปลงให้วันหลังแล้วกันครับก็คนที่คิดนะครับก็คือนายคนนี้นะครับนายลอเรนซ์นะครับซึ่งได้รับรางวัลโนเบลไพรส์นะครับตั้งแต่1920ก็120ปีที่แล้วใช่ป่ะ120ปีที่แล้วนะครับโอเคไหมก็รุ่นคุณปู่เล่าครับโอเคไหมก็ได้รับรางวัลร่วมกับซีแมนนะครับซึ่งคุณจะได้พบกับปรากฏการณ์ซีแมนเนี่ยอยู่ที่บทที่6นะครับเรื่อง Atomic Model นะครับก็คือเทอมหน้านะน่าจะเป็นบทที่2ของเทอมหน้านะครับโอเคไหมก็คือที่ไหนจังหวะนี้แหละเราขึ้นบทที่2เนี่ยนะครับเรื่องอันนั้นก็ยาวครับอันนั้นก็บทใหญ่บทยาวเลยครับโอเคแรงของลอเรนซ์นะครับแรงนี้นะครับที่ม้วนมืออย่างเงี้ยคือเราเรียกว่า Lawlens Force ให้เกียรติเขาเพราะว่าเขาเป็นคนคิดคนแรกๆนะครับก็สามารถหาได้จาก F เท่ากับ QV cross B นะครับก็คือคุณเอาเวกเตอร์ v นะครับ cross การ cross ก็คือหมุนมือขวานั่นแหละครับโอเคไหมแล้วคุณก็จะได้ทิศซึ่งทิศอันเนี้ยทิศ F เนี่ยครับมันจะตั้งฉากกับระนาบสีน้ำตาลครับระนาบสีน้ำตาลคือระนาบที่กินเวกเตอร์นะครับก็คือเขาเรียกว่าอะไรมันเป็นระนาบที่สอดรับ เวกเตอร์2อันเนี้ยเวกเตอร์ b และเวกเตอร์สีแดงเนี่ยเวกเตอร์ v และเวกเตอร์ b สีเขียวและสีแดงนี่นะครับโอเคไหมพอกวาด v ไป b นะครับแดงไปเขียวนะมันก็เป็นระนาบสีน้ำตาลซึ่งเวกเตอร์ f เนี่ยมันจะตั้งฉากทุกทิศทุกทางนะครับกับระนาบนี้นั่นคือคุณสมบัติทั่วไปนะครับนี่เป็นเวกเตอร์เวอร์ชันนะครับก็คือมีสเกลาร์ q นะครับเป็นตัวสเกลนะครับถ้า q ติดลบแรงก็จะติดลบแรงติดลบก็หมายความว่าประจุที่ติดลบก็จะมีแรงที่ตรงข้ามนะครับส่วนทางกับแรงที่เกิดกระทำกับประจุบวกนั่นเองครับในสูตรของฟิสิกส์ก็จะเป็นอย่างนี้นะครับส่วน v cos b ก็ว่ากันไปตามเรื่องราวของการ cross vector อันนี้นะครับแต่ว่าผมว่ามันน่าจะเกินเนื้อหาชั้นม.ปลายนะอันนี้ที่ผมเล่าให้ฟังเนี่ยครับคุณน่าจะพบในชั้นปริญญาตรีแต่ว่าผมเอาให้มันละเอียดเลยนะครับเพราะว่ามันจะเกี่ยวกับคุณจริงๆก็คือม.ปลายจะคิดเฉพาะเวอร์ชันสเกลาร์นะครับเราเทค absolute value ไปคุณจะได้ทราบนะครับว่าที่มาที่ไปทำไมเป็น QVB sin theta นะครับก็คือ F นั้นก็จะเป็นติด absolute Q นะครับก็คือไม่ว่า Q จะเป็นบวกเป็นประจุลบหรือประจุบวกก็ตามนะครับแรงจะเป็นบวกนะครับแต่ว่าทิศทางคุณก็ไปหมุนมือเอาตามกฎมือขวา QV cos B ตรงนี้เอานะครับคุณจะใส่ absolute หรือไม่ใส่ก็ได้นะก็คือถ้าคุณประจุติดลบมันก็จะติดลบก็หมายความว่าแรงมันจะสวนทางกับทางที่เป็นประจุบวกก็ได้นะครับแต่นี้ใส่ absolute ก็ได้โอเคไหม V ก็ความเร็วบวกนะครับสนามฟลักแม่เหล็กไฟฟ้าก็ฟลักของแม่เหล็กก็จะเป็นความหนาแน่นเส้นแรงแม่เหล็กต่อพื้นที่ก็จะเป็นบวกนะครับส่วนตัวนี้ก็จะเป็นไซน์นะครับสูตรนี้มาได้ยังไงก็พิสูจน์ยาวนิดนึงครับของดเว้นไว้นะครับคุณกดในอินเทอร์เน็ตน่าจะมีพิสูจน์ให้นะครับทำไมขนาดของ v cross b ได้ v p sin theta นะครับคือถ้าสอนทุกอย่างมันก็กินเวลานานนะครับเดี๋ยวมันจะไม่มีเนื้อหาสอบตามที่คนเรียนภาษาไทยเขาจะไปนะครับโอเคsin theta นะครับ theta ก็เป็นมุมระหว่าง v และ b นะครับโอเค v okay here there's the right hand figure yes what I told you is that we are going to use the if there is no one who will join the Zoom in order to get 100% of our area in the slide we are going to close the Zoom panel if someone want to join the class just let me know in Zoom chat or by hitting the live chatting program to me okay by approaching the live chatting program to me okay because I cannot see you anymore right now yes we are going to use the right hand we start from the vector v right to the vector b you just curl or rotate your four fingers note that this is the right hand okay not the left hand and after that your thumb direction will represent the induced force direction all right the magnetic force F points in the direction of your right thumb and you just point your fingers of your right hand in the direction of V and then curl them toward direction of B okay you rotate your four fingers okay this is the right hand rule in order to determine the direction of the magnetic force all right another way นี่นะครับผมบอกว่าผมจะไปหารูปมาให้มันมีอยู่ในสไลด์แล้วผมก็ตื่นตระหนกไปคิดว่าไม่มีรูปให้คุณนะครับมีนะครับโอเคand another way is that if you don't use your remaining four fingers to curl you can use simply three fingers like this okay this is the first finger and the second finger right you just lay it like in the same direction as vector B and you use your thumb direction thumb finger your thumb to represent the vector V and after that the middle finger will represent the direction of the force okay this is the three fingers rule it is quite close to the right hand rule right but I don't know which one you prefer for me I think this one is quite simple and easy to understand but maybe you are the son of Albert Einstein right? maybe you prefer this one is a little bit complicated but it works also okay it works too okay in figure 10 in this figure the thumb points along the motion direction okay which is the speed the velocity vector of the positive charge. Okay, please note that the right hand is valid for the positive charge. โอเคนะครับสำหรับใครที่จะเข้าไปดูที่ YouTube ก็พิมพ์ชื่อที่ YouTube อ่ะเดี๋ยวผมชี้แจงให้คุณดูว่า YouTube มียังไงนะครับก็no not this one นะครับอีกช่องหนึ่งก็จะเป็นช่องของ OBS นะครับคุณจะเห็นผมนั่งด้วยนะครับโอเคไหมตรงนี้นะครับคุณจะเห็นผมหมดเลยนะครับแล้วก็อันนี้เป็นสะท้อนไปจากห้องซูมของเรานะครับแล้วก็อีกช่องหนึ่งครับซึ่งเป็นอีก account หนึ่งของผมนะครับใช้อันนี้ก็ภาพชัดเหมือนกันนะครับอันนี้ก็ภาพชัดมากครับก็where is that อันนี้นะครับก็จะเป็นอีกมุมกล้องหนึ่งครับที่จะเห็นผมนะครับโอเคไหมตรงนี้นะครับก็คุณก็เลือกดูเอาครับอยากไม่อยู่ตรงห้องซูมก็ได้นะถ้าอยากอยู่แบบส่วนตัวนะครับก็ไปโอ้โหโอเคyes the four fingers this one okay the second finger along the magnetic flux density the vector b and the third finger which is the middle finger will represent will go along the induced outcome force okay which is the Lawlens Force here okay it's up to you I don't know which one this one is taken from a book that is used in bachelor degree actually but for me I personally recommend you to use this one it's quite simple okay there are many ways to find the induced Lawlens Force right and we will talk about the sort of function but I'm gonna bring you to that plot psi x right here you would have oh no my god okay psi start from 0 to 2 pi right that's the whole wavelength okay the whole cycle and what you can see is that if you take a look at only this portion if you take a look at only 0 to 2 pi like this okay you will see that the maximum value oh no the maximum value where is that the top the highest the greatest value for the sine function this is the maximal point right this is the greatest value we can get from psi x this is the lowest the minimal value right we don't pay attention to that we are interested in this one the maximum value right so what is the important thing then because we have psi theta which is equivalent to psi x there right the force will be maximum once we get this one right which is the pi by 2 right pi is 3.14 is around 1.56 blah 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 something like that 1.57 okay 1.57 is the radian the angle in radian that we can get the maximum value for psi x and in terms of degree x should be 90 degree right so that we can get the highest amount of psi x okay it means that this expression will return the maximum value to us once the theta is 90 degree or 1.57 blah 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 okay yes we will get the maximum value once we take the operator max okay with respect to any value of theta อันนี้เป็นความรู้ชั้นปริญญาตรีแล้วครับก็คือ take maximum okay this is taken from the stuff in bachelor degree you take the maximum to this for whatever theta and what we found is that theta at 90 degree will give us the maximum value of the function psi as you have seen in the plot of the sine function right And once we substitute theta by 90, this is only number 1, right? The maximum value of the psi is the psi function. It's number 1 here. You can see the maximum we reach number 1. So that's why we have here number 1, right? Number 1 for psi of 90 degrees. So we don't have to write number 1. So finally, there will be only 3 terms here, the product of Q, V, and B. Okay, so that's the maximum to better understand by considering the actual problem. Okay, we consider the beam of protons. You know protons, right? Protons is the you will see later in I don't know in proton Wikipedia. Oh, it's German. I'm sorry for that. My God. Here, proton is a particle which is made of up quark and down quark. Okay, you will know up quark and down quark later once we arrive at chapter 7. Okay, proton is a particle that is made of 2 up quarks and 1 down quark. And yes, it's a particle. Right here is a positive charge. Right, proton is a positive charge. Where is the atomic model? I'm gonna bring you to atomic model. Okay, here is the nucleus, right? We will talk about nucleus in chapter 7. We will talk about the whole model, the atomic models in chapter 6. A proton stay inside the inside the nucleus, and sometimes if you have a really high energy, you can annoy. Okay, you can make the vibration to the nucleus, and sometimes the proton will get out of this nucleus. Okay, and that's the situation to this problem. Proton is moving on the xy plane. This is the z plane. This is the x, y, and z. Okay, the miracle thing between x, y, and z axis is at among x, y, and z axis is that if you rotate your 4 fingers from x to y, your thumb direction will be the z direction axis. Okay, the positive z direction axis. Okay, in this scenario, someone has disturbed the proton, and proton is moving on the zx plane. Okay, what is the zx plane? Or the xz plane, whatever you call. Okay, the plane that lies on the x and z axis. Okay, that cover x and z axis. Okay, that's called xz plane. If you say xy plane, it means the plane that cover the positive the x axis and the y axis. Okay, if you say yz plane, it means the plane that covers z axis and y axis. But here for us, the yellow one or the brown one here is the xz plane. The xz plane covers z axis and x. Okay, x axis. In this scenario, someone disturbed the proton, and the proton is moving on the z x axis or the xz axis, and someone has measured the motion direction of the proton. It is found that the motion direction of the proton is done at it can be measured at 30 degrees from the z axis, and in this scenario, the magnetic flux density vector is pointing exactly the same in exactly the same direction as the positive z axis. Okay, exactly 30 degrees. And after that, they ask you the proton be moved through a uniform magnetic field with magnitude of 2 Tesla directed along the positive z-axis here, along the positive z-axis. And next detail is proton have a velocity of magnitude 3 times 10 to 5. Okay, it's like 3,000 at angle 30 degree with respect to the positive z-axis. Okay, 30 degree from the positive z-axis. And given the charge of the proton be, of course, it's a positive charge, right? So you can see it, like this. It's in 1.6, but actually it's not exactly 1.6. Okay, for simplicity for us in high school level, we're going to use exactly 1.6. It should be 1.602 blah blah blah. If you want to see exactly the value of the proton charge. Right here, it's somehow it is, okay. 1.602 10 to negative 19. Okay, that's the exact number for electron. But electron will be negative. Okay, for proton we have simple 1.6 times 10 to negative 19 coulomb. Find the force on the proton. Okay, that's the main target to us at this level. Okay, find the induced force, right? The Lawlens force. That's what we can say. Of course, you need to find. Okay, this is the solution, right? You have to find two things, right? In physics quantity. You have to find first direction, right? And another one is magnitude, right? Of course, the direction could be found by using the right-hand rule, right? And the magnitude could be found from F equal to Q. The absolute value Q VB sine theta. Right, that's a technique, right? Yeah. Let's talk about first the direction. Of course, the formula for the direction is F is equal to Q V cross B, right? And the magnitude formula is somehow this, right? Of course, you have to start from the vector V to vector B, the second vector, right? You get the time direction as the induced force direction. Okay, from V to B, here is the way you can rotate your finger, okay, your four fingers from V to B. And after that, your time direction is gonna point upward or downward in this scenario ขึ้นหรือลงครับอย่างงี้ถ้ามือขวาแล้วคือถ้าใครอยู่ที่ Streamlab ผมจะหมุนมือให้ดูนะครับโอเค V to B โอเคเพราะว่ากล้องมันถ่ายเห็นมือผมด้วยนะครับ V to B โอเค but I don't know what should you do in Zoom โอเค V to B เนี่ยจอที่กล้องของ Zoom นะครับ V to B will be somehow like this okay V to B so I don't know. You can imagine, right? You can realize how you can find F direction. Yeah, you cross your four fingers from V to B, and the induced force will be will point downward or upward what do you think ชี้ลงหรือชี้ขึ้นครับอย่างงี้ V ไป B มือขวาหมุน4นิ้วจาก V ไป B นิ้วโป้งของคุณจะชี้ลงหรือชี้ขึ้นครับอันนี้ so it should be upward or downward should we the answer is down okay downward the force will point in this way okay in the negative y direction this is the induced force okay that's the direction we have completed the determination of direction already if the next one is the magnitude okay magnitude is magnitude of the force right can be computed from this one okay I'm gonna open the new figure to you no new page I'm sorry for that okay right here the magnitude right we're gonna say what is Q is 1.6 times 10 raised to negative 19 coulomb right V is 3 times 10 to 5 okay meter per second one important thing I need to mention to you okay even we didn't meet we didn't see each other in physics before but I need to mention to you is I need to mention to you that if the velocity or the speed of any particle or any object is close to the speed of the light, you cannot simply use all of these formula. You have to use the Albert-Einstein relativistic theorem. Okay, if the speed is very very close to the speed of the light, like 3 times 10 to 8, this formula will not be valid. You have to use the speed formula from relativistic theorem. I would introduce you somehow, but in this scenario we have only 3 times 10 to 5, okay, which is not so close to the speed of the light. We can use the typical formula in physics, but if you have some speed that is close to the speed of the light, we cannot use that. Okay, relativistic speed เราไม่ได้พบกันในฟิสิกส์ก่อนหน้านี้ผมไม่รู้ว่าเขาสอนคุณเรื่องความเร็วสัมพัทธภาพไหมครับก็จะนะถ้ามันwhere is the formula for that here right here okay the speed is somehow right here นะครับก็จะความเร็วมันจะประมาณเนี้ยมันจะมีส่วนของแฟกเตอร์แบบนี้ขึ้นมาด้วยรูทอะไรพวกนี้นะครับโอเคไหมผมไม่ได้เตรียมแบบhere this one okay it depends on the observer okay ก็นะมันจะต้องมีรูทอะไรพวกนี้นะถ้าความเร็วคุณใกล้ความเร็วแสงนะครับแต่สำหรับของเรานี้มัน30 ยก 5ใช่ไหม3 คูณ 10 ยก 5ก็ไม่ใกล้ความเร็วแสงก็ใช้สูตรปกติไปแต่ผมชี้แจงไว้ก่อนนะครับเดี๋ยวจะหาว่าอาจารย์สอนไปงั้นไม่ได้แบบกว้างขวางครอบคลุมผมบอกคุณไว้ก่อนนะครับก็คือถ้าไปถือว่าคุณไปทำจุดฟิสิกส์โอลิมปิกอะไรข้างนอกความเร็วมันใกล้แสงห้ามใช้สูตรนี้ให้ไปใช้สูตรสัมพัทธภาพซึ่งรู้สึกผมมีอยู่ในบทที่6เรื่องอะตอมิกโมเดลมั้งสูตรความเร็วสัมพัทธภาพครับมีโจทย์อันนึงนะที่อิเล็กตรอนมันวิ่งความเร็วสูงมากนะครับใกล้ๆแสงนะครับโอเค but proton in this scenario it is quite safe to use the typical formula okay only this one and one important thing the magnetic flux okay magnetic flux density is 2 Tesla so R will be is 2 Tesla like that all right And now it's time to substitute all these quantity Q, V, B, psi, theta. Oh, I need to mention that theta is 30 degrees, right? The angle between V and B is 30 degrees, and we can substitute everything into this one. 1.6 times 10 raised to negative 19 coulomb, and velocity 3 times 10 to 5 meter per second, and B is 2 Tesla. Okay, and psi of what? Psi of 30 degrees or pi by 6, right? Whatever unit angle unit you can use, it's no problem, even it's radian or degree. Okay, after that you pass them to the calculator. Okay, you get the results. Let me use the calculator to you. What is that? It's 1.6 E negative 19 star and 3 E 5 star 2 times psi of 30 dec, right? So we're gonna get the result 4.8 E minus it means we get the force as 4.8 times 10 to negative 14 Newton approximately. I think, yes, it should be approximation. Okay, we get the force somehow. I'm not sure if it's correct. Yeah, it's somehow it is 4.8 times 10 to negative 14. Okay, and let's move to the next example. We have a next example like this. Proton moves a proton again. Okay, the same particle. Keep in mind that this value is a little bit far from the speed of the light, right? So it's no problem. We can still use the typical formula ครับถ้าใช่นะครับพิมพ์ชื่อมาที่ YouTube นะครับไม่เป็นไรครับดูที่ช่องไหนก็ได้ครับไม่มีปัญหาถ้าผมแบบว่ามองไม่เห็นคุณที่ซูมนะเพราะว่าผมปิดมาแล้วผมนึกว่าเข้ากันหมดทุกคนแล้วนะครับโอเคไหมก็ต้องการใช้พื้นที่ให้เต็มจอมากที่สุดนะเพื่อคุณจะได้เห็นครับก็เลยปิดซูมนะครับขออนุญาตปิดหน้าจอซูมโอเคplease keep in mind that the speed is not close to 3 times 10 to 8, right? Which is the speed of the light or the electromagnetic wave in the vacuum. So we can use the typical formula. And they say there is no artificial magnetic flux. There is only Earth's magnetic field, which is about 55.0 microtesla. But don't believe in this value so much because it depends on area. Okay, for example, if you ask the Google for let's say, for example, Earth magnetic flux density, it might be different. Okay, it might be different. Okay, Earth magnetic field can be from 0.035 to 0.07 millitesla. It depends on where you measure, but yeah, here you can. They say the Earth magnetic field start from 25 to 65 microtesla. Okay, so the value may not be exact. Depends on where you live on Earth. Okay, it depends on the country where you live. When the proton moves eastward, what is that then? Eastward. Eastward means you have south, west, north. Okay, where is eastward? East on the right hand side, west on the left hand side, north in the upward direction, right? Sorry, south is in the downward direction. Okay, down direction. And yeah, the proton is moving eastward, and the magnetic force acting on it is directed straight up. Example is there? No, there is no figure at all. So I need to draw it so that we will not forget. Okay, we start from the 3D Cartesian Coordinate. Okay, what is that? It means we have the x-axis, like this positive x-axis. We have y-axis like this, and we have a z-axis like that. And they say the electron is moving. Here is electron is moving in this direction to eastward, right? To the right side. If you look on top of this, electron is moving to eastward, like to Chonburi or to Rayong or to something like that. Okay, and yeah, you on top of this, the top view will say the electron is moving to the right hand side, and they say the induced force happens in the straight upward direction. It means that the force is pointed. The force points in this way, in the positive z-axis. This is the F direction, and here is the V direction. Okay, so when it moves northward, no magnetic field acts on it. Oh my God, this is the first scenario only. Okay, this is the first scenario. The second scenario is that, okay, we have to draw again the x, y, z axis, and z axis like this, right? They say once it moves to the north direction. North direction means this is so when it moves to the north, electron moves to the north like this. There's no F. Okay, F is 0. There's no F at all. F vector is 0. There's no F that take place at all that exists in this scenario. In the second scenario, no magnetic force acts on it. Given a charge on the proton is 1.6 times 10 to negative 19 again. Okay, the same value at this problem here, 1.6, and the mass of the proton is around 1.67 times 10 to negative 27 kilogram. Okay, yeah, it's very light. So we get a mass of the proton, we get a charge of the proton, and the first question is, what is the direction of the magnetic field? What is the direction of the magnetic field in both scenarios? Because the magnetic field doesn't change in both scenarios. What do you think then? The first question is direction. Oh, sorry. What is the vector B? Okay, what is the vector B in these two scenarios? In these two scenarios, what is the vector B then? What is the vector B what should the vector be? Of course, you know that the Lawlens Force is computed by F equal to Q V cross B, right? Yeah, it's computed by V cross B. You start from V to whatever B, and then you get the vector F. So from the first scenario, if you apply this right-hand rule, you have to rotate your forefinger, okay, curl your forefingers from V to B. What direction of B should what should the direction be so that we can get the F direction pointing upward like this ต้องเป็นทิศไหนดีครับทิศ B จึงจะทำให้ F เราจะได้ F ชี้ขึ้นอย่างนี้โอเค Of course B should lie on the xy plane, right? B can be like this, oh, like this, okay, on the xy plane. But which direction is the exact one? Okay, otherwise, if we don't have any more knowledge about that, we're gonna say the vector B, the magnetic flux density, should point any direction on the xy plane. But once we take into account, or once we consider the second scenario, they say if the electron moves northward like this, okay, to the north, there is no F at all. So what is the situation? What is the requirement that once we don't have result of the cross vector, the cross product? The cross product will never exist if both vector points in the same way, in the same direction. What is the reason why I say that? If you take a look at this, okay, if you think about it, let's imagine if we have I, J, K, and if the first vector be, for example, 1, -2, and 3, and if another vector is pointing in the same way, for example, this one is 2, -4, and 6, please note that the second vector points in the same direction as the first vector, but it has different magnitude. And if you start computing the value of this determinant, you're gonna get -2 and 6 and plus J 3 and 2 and plus K, what is that, 1 and -4, right? And another one is minus of 2, minus K, and 2 and -2, and then plus, minus -4, 3, I'm stupid. I should write first unit vector I, and after that -4 and 3, right, and minus the last one J, right, unit vector J, 6 and 1. All right, here you would get -12 I plus 6J and -4K, and here you get plus 4K and plus 12I and minus 6J. So once you combine everything, you get vector 0. Okay, so the cross product will remain 0 if both vectors have the same direction or share the same direction. So in this case, the output after the cross product is 0. So it means another vector, this is the velocity vector, right? This is the vector v for electron. It means the vector b, the flux density, should point in this also in this way. Okay, so we don't have to worry about what direction exactly the vector v be, the vector b be. So yeah, we know exactly first. Okay, พอเข้าใจได้ไหมครับพอเข้าใจเนาะก็คือเวกเตอร์มันจะคอสกันเป็น0ได้นะครับเมื่อเวกเตอร์2อันนั้นผมยกตัวอย่างให้ดูตรงนี้นะครับเมื่อเวกเตอร์ทั้ง2อันชี้ไปในทิศเดียวกันนะครับก็สถานการณ์แรกเขาบอกว่าถ้าอิเล็กตรอนวิ่งไปทางทิศตะวันออกนะครับแล้วแรงมันจะยกขึ้นใช่ไหมมีทิศยกขึ้นดึงขึ้นมาหาเราพุ่งเข้าตาเราถ้าเรามองจากข้างบนครับก็ v ที่เป็นไปได้มันก็อะไรก็ได้ที่อยู่บนระนาบ x y ใช่ไหมครับแต่ว่าโอ้โหคำตอบมันมีอนันต์เลยนะทิศของเวกเตอร์ b พอมาดูสถานการณ์ที่2นะครับเขาบอกว่าถ้าอิเล็กตรอนวิ่งไปทางเขาทำการทดลองครั้งที่2เนาะถ้าอิเล็กตรอนวิ่งไปทางทิศเหนือนะครับปรากฏว่าแรง F มันไม่มีเลยไม่มียกขึ้นไม่มีดึงซ้ายลงขวาลงล่างดึงกลับดึงไปทางขวาไม่มีเลยนะครับไม่มีแรง F เลยนั่นหมายความว่าตามกฎของเวกเตอร์ก็คือเวกเตอร์อันที่2ที่มาคอสมันก็ต้องทิศเดียวกันครับเพราะ v cross b ถ้าเป็นเวกเตอร์ทิศเดียวกันปุ๊บอันนี้มันจะลง0ทันทีครับเพราะ0ไปคูณกับ q ต่อให้ q เป็นเลขอะไรก็ช่างมันก็0นะครับโอเคไหมเพราะว่าเวกเตอร์มัน cross ออกมาแล้วเป็น0ครับก็เราก็เลยได้คำตอบ so we get the final answer for the direction that the magnetic flux density will point northward. Okay, magnetic flux density. The answer is to the north. Okay, and let's talk about the second. เคลียร์ไหมครับเคลียร์ไหมเอ่ยไม่รู้เรื่องบอกผมเลยนะอาจารย์ครับผมไม่รู้เรื่องครับหรือว่าขออีกทีครับอาจารย์หรือว่าติดขัดตรงไหนโปรดถามได้เลยครับโอเคไหม if you are clear about that we are gonna move to the second question what is the strength of the magnetic force when the proton moves eastward the strength okay what is the strength what does that mean strength mean strength right it means that they ask you what is F which is the absolute value version of the F okay what is that it means we're gonna say strength mean magnitude means magnitude okay it means the magnitude all right yes we need to use the typical formula right F is QVB sine theta and Q is of course we know Q is 1.6 times 10 to negative 19 again coulomb right and V the velocity is 1 times 10 to 5 in this scenario B what about B then B is the magnetic flux density the strength is 55 microtesla so it's going to be 5 and 5 times 10 to negative 6 Tesla and after that we need to know about theta the angle between V and B and as you know in this scenario we can be sure that vector b is in this way. So the angle out of this, it should be this one, right? And this angle is the right angle. It's 90 degree, right? Theta is 90 degree. So yes, of course, we would say theta is 90 degree. And after that, you can, oh my god ให้หน้าผิดครับขออภัยครับ all right yeah after that we will substitute all these four variables or quantities into the expression f qb, right? q 1.6 times 10 to negative 19 Coulomb, right? v is velocity 1 times 10 to 5 meter per second เวลาหมดยังเวลาผมต้องปล่อยคุณเท่าไหร่เนี่ย9:40 right เฮ้ยหมดเวลาแล้วสิหมดแล้วหรือยังครับฮัลโหลครับเวลาหมดยังเลย v and b is ไปเรื่อยนะครับผมไปเรื่อยนะ55 tends to negative 6 Tesla and sine of 90 degree. You know sine of 90 degree is number 1, right? And after that you pass this value into the calculator. จบอันนี้เดี๋ยวปล่อยนะครับโอเคเดี๋ยวเลิกครับผมก็ไปเรื่อยนะครับไม่ได้ดูนาฬิกาเลยนะครับ1.6 e minus 19 and 1e5 times 55 e minus 6 times 1, which is the result from it's 8.8 e minus 19. It's 8.8 times 10 to negative 19 Newton. Okay, and I hope it's correct. 8.8. Yeah, 8.8 times 10 to negative 19. ถูกไหมครับผมต้องปล่อยคุณที่940เนาะเพราะมันต้องเบรก10นาทีนะครับโอเคใช่ไหมครับขอเสียงหน่อยครับทุกคนได้ยินผมเลยผมต้องปล่อยคุณที่940เนาะเพราะว่ามันต้องเลิก10:00ครับแต่ว่ามันต้องเบรก10นาทีใช่ป่ะก็โอเคคือไม่ใช่อยากเลิกสอนนะเพียงแต่ว่าผมไม่มั่นใจเวลา940เนาะตอนนี้มัน944แล้วนะครับก็เลยมาแล้วโอเคthen see you on on Friday. Oh no, on Wednesday, right? We will see each other at the school, right? Next semester will be the. I hope that we could do the experiment in the laboratory. I will talk about your co-teacher later. พบกันวันพุธหน้านะครับคาดว่าน่าจะได้ทดลองนะเดี๋ยวผมก็ลืมไปเลยว่าต้อง list รายการของให้เขาโอเคsee you on Wednesday บ๊ายบายครับสวัสดีครับแล้วก็การบ้านนะครับการบ้านก็คือ homework is something about one problem okay one problem related to one problem about the Lawlens Force okay Lawlens Force เดี๋ยวใส่ให้ใน Google Classroom ครับ see you on Wednesday บ๊ายบายครับสวัสดีครับใช่หรือเปล่าเนี่ย840ก็ต้องเลิก940น่าจะถูกนะ Oh no, my god. Oh no, my god. And this one. This one, right? Yes, seeing the chat in Zoom, right? Chat in Zoom. We have our okay, right here. Acronym. To this one in national attention similar see what to Patragon inside to this person in continent okay. Continent okay, that's it. And we create the homework. Nine online, then we create the homework, which is the assignment. I don't know, the homework is the second homework, right? For both homework is the homework at homework is that today is 10.06.20. Related to the Lawlens Force. Yes, the force. Theta yeah. Alpha both class in 1 point. is the date is today 10, right? We're gonna say 17 and 1 p.m. Side both, and the night lecture is some here.สุดท้ายธนกฤษ23 and after that you're gonna express to here, download, and yes, this and a good note. Let's continue. Alright, move to this one. Go see, download drive. Let's download drive. Yes. Next section will be M605. Open this classroom. Terminal. SCI. Today is 10, 6, 20, 22. And our set dip. We have 1 to 26 in our set dip of this one. Yes. What do we have here? 12, 10, 20, 7, rotate, touch, 11, crit, ชะนนSiva 19 number 4 number 9 number 5 number 8 number 18 number 24 26 14 21 1 3 23 and 22 and 2 right no one more right 12 what happened oh my god you have to go to October Six and 15 6 and 15 and are we no to 10 oh my god we have to finish at 10 or why not still with to 10 not 20 10 oh my god stillกูว่าแล้วทำไมมันเร็วจังจบเร็วมาก okay 6 and 15 6 and 15 Gene 6 and 15. Nine. After that, cost. Second 9 we have to get the desktop shortage 1 2 right. This is 4 I think. Three. And then use this School. Finish. Okay. Hello test. 1, 2, 3. Okay. I think the time is right now for. I have to look at the people here. Oh my god. Okay. Hello test. This is the section for M605. Sorry for that. I didn't watch. You are trying to get into the Zoom meeting, right? Okay. Now let's continue our lecture.ของ604นะครับตะกี้ผมดูเวลาผิดไปนะครับเลิกเร็วก่อนเฉยเลย20 นาทีผมนึกว่าต้องถอยไปอีก20 นาทีครับต้องขออภัยเขาด้วยนะครับปล่อยเลิกเร็วไปเลยครับโอเคคนแรกของ605ครับช่วยพิมพ์โอเคเยี่ยมมากครับธนกรครับเป็นคนแรกเลยธนกรช่วยแจ้งนิดนึงครับว่าเป็น605ครับซึ่งทำได้ดีมากครับโอเคOkay. Good morning, every student. Welcome you to SCI33205, which is the physics number 4. This is the section for M605, right? And yeah, we have finished on Friday. We have finished it on Friday. Something about the dot product, right? We call in this talk, in this lecture, and I'm gonna bring you to the new file, right? Because it's better. I have added one more figure to us. If not okay, where is that? Something here, right? Okay, the Zoom panel here will be open for a while. Okay, after that it's gonna be closed. In if you want to join in several ways, okay, you can go to for example this YouTube channel. It's in a live stream right now. Okay, you can see me right here. You can see even the another view, which is taken by the mobile phone, okay, onto the iPad, and here is exactly the screen on the monitor. What you can see, this is in the YouTube. Another YouTube would be this one. Okay, just use the code from our subject, right? SCI33205. You will see many live stream and choose whatever you want, which version you want to see. Okay, for example, this one is in Streamlab. Okay, it's taken by the mobile phone, and you can see it from top view of the iPad monitor. Okay, iPad screen. Another one is this one, okay, which is the copy version from the from our Zoom meeting room. Okay, if you feel comfortable, and you can write your name in the chat box. Okay, so that I can recognize. I can see you every channel. Okay, up to you. Here you can also see me in many in different camera angles. Okay, let's talk about our story. Okay, here 3 people. Of course, we have seen the positive charge version right there and the negative charge version, and we can determine the we can determine the induced force, right, from the right-hand rule. The expression is QV cross B, right? You just rotate your four fingers from V to B, right? From this vector here to this one, and then your thumb finger direction, your thumb direction will go in this way, and that's why we get the induced force direction. Okay, in physics, we have to determine two things, right? The first one, if that quantity is a vector quantity, we have to determine first the direction, and after that we're gonna find the magnitude, right? So in this scenario, we consider the positive charge and it's pointed in this way. But for the negative charge, the force will be in the opposite direction. You will see it later from the formula. Okay, in this scenario, if it's not a right triangle like this, if your particle is moving like this, and you have the magnetic flux density pointing in this way, the V to B will be this one. Okay, from you just rotate your forefinger from V to B. Okay, you will rotate your forefingers like this, and the thumb direction will point outward. Okay, and then the induced force will be in the same direction as your thumb direction. Okay, and the person who observed this phenomenon is this person is this scientist or physicist. His name is Hendrik Anton. 80 years, blah blah blah, 80 or 90 years. Okay, he was a Dutch physicist, and he's famous because he received the Nobel Prize in Physics in 1902 with another person, and also this person is also famous, Peter Zeeman. Okay, you will see the Zeeman effects in, I think, in chapter 6 about atomic model. Okay, both will both receive the Nobel Prize in Physics. Okay, if you want, okay, someone to recognize you in the future, just go ahead in physics. Oh my God! And start doing experiment or start studying the theory of physics, and the people in Nobel Prize organization will look for your work in and then they will give you the Nobel Prize if they are really impressive with your they get impression with your work. Okay, yes, this person is the physicist who observed the Lawlens Force. Okay, from V to B, and if you get the F direction, the induced force direction. What is this expression then? Okay, I'm not sure whether usually we can see this expression in the high school level or not, but in bachelor degree you should see it in the first subject of physics and so on. The force is known as Lawlens Force, and it can be computed by F equal to QV cross B. Okay, you got to know the idea of cross product of two vectors already, right? I have introduced you to the three-dimensional system, three-dimensional Cartesian coordinate. You have the x, y, and z plane, right? You have unit vector I for the x-axis, unit vector j for the y-axis. You have unit vector k for the z-axis. And after that, for whatever cross product or for whatever two vectors, you can compute the cross product like this, and the result turns out to be still the vector quantity. And for us here, yeah, we can apply the cross product at this step. Okay, V cross B, and we have Q, which is scalar. Okay, Q is a scalar, is a constant. Okay, Q is scalar. It means the quantity without any direction, but this one is still a vector quantity. Okay, it's still vector, because if you take a look at this, we get the answer. We got the answer last time in terms of vector quantity. So yes, of course, we get a vector quantity here. And yeah, the X symbol or the multiplication sign means the cross product. One important thing in this expression is that you need to realize that the charge can be either positive or negative, right? For example, if you talk about the nucleus of the helium-4 okay, that's alpha particle. It's also a kind of positive charge, and it's 2 times electron charge, right? And yeah, on the opposite way, if we, on the other hand, if we consider the negative charge, for example, electron, okay, proton is positive charge, electron or some muon or something like that. Those are negative charge, okay, or any object that you throw away electron into that particle, you will get the negative charge. And what is the result then? If your Q is positive, your F will follow the result from the right hand rule. V to B, this is vector B, right? Your F will be in this way. Okay, this is valid for the positive charge. But if your charge is negative, like this, the induced force will be in the opposite way to the positive one. Okay, you rotate or you curl your 4 fingers in this scenario, and the force will be directed in the opposite way, and that's the result for only the negative charge. This is due to this expression, okay, because when Q is negative, the vector will be directed in the opposite way. The next part in physics, you need to find the magnitude, right? You could find the direction from the right hand rule. You rotate your 4 fingers from V to B, and you get the F direction, okay, the induced force from your thumb direction. That's the first manner. Another way is that, okay, this is taken from the book in bachelor degree, but I don't know it's widely spread or it's widely used or not. You laid out your first 3 fingers. You just lay your thumb to direction of the particle motion of speed of velocity vector, and after that you let your 4 finger, okay, to the magnetic flux density vector, and after that the outcome will be your middle finger. Okay, it's going to point in this way. Okay, and that's the outcome direction for the induced force or the Lawlens force. But personally, I would recommend you to use this method. It's easily understandable. It's not difficult to understand. Okay, you start your 4 fingers from the velocity vector V to B, and this rotation will give you the type direction as the direction for the induced force. Okay, but the next thing in physics is that we need to determine the quantity, right? The magnitude of the force will be only the absolute value of the vector version. In as we know, we have Q and parenthesis V cross B, right? This scalar and vector cross product, the cross product of the vector. Yes, once the absolute value operator cover those 2 components, of course, we have scalar and vector. The absolute value can be separated to cover only the scalar quantity. Okay, and we don't know whether the the charge is positive or negative. So we have to leave the absolute value like this. And for the second part, the cross product result, the absolute value will also cover that amount. Okay, now the absolute values operator are separated for both components, for both parts. And from the theory of vector cross product, the absolute of the cross product can be decomposed into the absolute value of the vector v, okay, the first vector, and the absolute value of the second vector b. Apart from that, we have sinusoidal function of the angle. The angle of what? The angle between v and b, okay, between two vectors. And of course, the scaling factor here, or the scalar q, will remain the same. Okay, nothing changed, but we still need to leave the absolute value from the definition, and you can relax it later. Just simply say qvb without absolute value, but usually it should be positive. Okay, the magnitude should be positive. It is impossible that the magnitude or the absolute value will be negative, right? For example, if you have absolute value of -1, it's going to be number 1, right? Absolute value of 5 will be, of course, 5. And absolute value of I minus 2j plus 3k, what is that? It's going to be square root, right? Square root of, it will be square root of 1 square plus minus 2 square and plus 3 square, right? And of course, you will get square root of 1 plus 4 plus 9, right? Which is square root of 14. Okay, the absolute value can cover both scalar quantity and vector quantity, like this. Next thing, okay, what else? Okay, let's talk about the unit. The unit of the force. Okay, unit is important for us in physics. It's not like the mathematics subject, right? They don't care anything about the unit. Okay, the people in mathematics, but for us, we are very close to nature, and any quantity should have its own unit. The force that we could get from this expression is in the unit of Newton, and the speed will be velocity in meter per second, right? In the typical SI system unit, and B, which is the magnetic flux density, it's equal to Weber per square meter, but we would simply say Tesla, okay, because it's shorter. All right. Yes. If no one will join Zoom more, let me close this panel so that we can use 100% of the area to the screen. Okay. The unit for the magnetic flux density is Tesla, and the angle between two vectors V and B is theta. It's not irrelevant. Okay, you can use whatever the unit for the theta. Theta can be in degree or in radian. Okay, it's up to you. Now let's talk about the next feature of this formula. What is the maximum value for the induced force? Okay, you know that induced force can be either in the angle between V and B can be either in radian or degree, right? But in this expression, you can see that the force has the term of sinusoidal function, which depends on theta. So theta will be only the variable that varies in this expression, right? The shaft is the same, is fixed, right? The velocity of the particle can be measured, and the magnetic flux density can be also known, but the angle can be varied. Okay, you can choose whatever direction to let the particle propagate or move. Okay, so theta is the one that can change. So what is the maximum value for psi function then? So let's go to this one. I don't know. Okay. Psi x plot psi x. Okay. Here is the plot of psi x, and let's talk about the first full cycle of the psi function. You can see that psi starts from 0 here. Okay, this is the y-axis, the value for psi x, and here is the x-axis, the angle theta. Okay, in our scenario, you can see that psi theta starts from 0. One theta is 0. It goes higher and higher until it reaches the highest point. The highest point is equal to 1. Okay, psi theta can be maximally 1, and the value of theta or x that could give us the maximum value will be this one. So it's pi by 2. You know that pi is 3.14, right? So this one is gonna be 1.57. Okay, in terms of radius, but in degrees, we would say this is 90 degrees, right? Once we let theta be 90 or x be 90 degrees, we would get the maximum value from psi as number 1. We don't talk about negative 1, right? We want we consider only, we are interested in only the positive value, right? So the minimum value will be here, which is I think 3 pi by 2. Yes, 3 pi by 2. Here is pi by 2, right? 3 pi by 2 will be the angle that you get the minimum value. Okay, and yes, let's get back to our scenario. Yes, psi will be maximally number 1, and once we take the maximum operator to towards the product, right, Q will be psi theta, we will get the maximum value of the force, and we take the max with respect to theta. From what we have seen in the graph, theta at 90 degrees will be the maximum value for psi. So we move the max operator to the sinusoidal function, the psi function, and after that we get maximum value at 90 degrees. So psi 90 degrees will be number 1, right? So this one, Q will be here, will be simply multiplied by 1, but we don't need to write down number 1, right? Because it's only the identity for multiplication. So the maximum value of the force will be QVB only, okay, without psi of anything, because psi 90 degrees will give us number 1. Okay, now let's consider the first example in the topic of in the problem of Lawlens force, right, or induced force due to the shaft, okay, that moves in magnetic field. Okay, a beam of protons, right, move through this magnetic field. So what is proton? Proton Okay, if you take a look at the Bohr atomic model, we have mainly two parts, right? Here is the central part, right? The core part. We have nucleus. Okay, we have nucleus, and here is the second part, which is the orbits for electron, right? That could move around, but it's in three-dimensional system, not in the planar form like this. Of course, in the nucleus we have neutron and proton, right? Proton is a positive charge. Neutron doesn't have any charge at all, but it is a particle inside to attract all the proton, because proton will have compulsive repelling force to each other, because they are of the same positive charge. They're gonna repel each other, but neutron just stay there to keep them to stay together. Okay, sorry. But if you have really high amount, a large amount of energy, okay, you throw away the energy. You throw the energy into this nucleus. It is possible that the proton could go away from the nucleus, and there we come to the scenario for us in the problem. But I would say proton is not the smallest particle unit. Okay. Okay, proton is not the smallest particle. It is actually made of up quark here. Okay, two up quarks and one down quark. Okay, you will see more detail. You get to know more detail about up quark and down quark in chapter 7 in the next semester. But at least you know something about proton, right? Proton can be accelerated and move with the speed. And let's say if our scenario here is proton, okay, it moves in this direction with motion direction vector v, or the speed vector or velocity vector v, and there is magnetic field with the flux density, and it points in this direction along the z-axis. Okay, this might be a little bit strange, okay, but it's not too difficult. You have here the z-axis, x-axis and y-axis. Okay, usually x should be in this way, y and then z, right? But it's also possible if they wanna lay down like this, lay everything down like this. The yellow one will be the so-called xz plane. Okay, yellow one here is known as xz plane. What is the plane then? Plane means the smooth area that cover million points. Okay, continuous point. And what is the reason why we say xz plane? Because this plane cover the x-axis. This plane is made in the same level as the z-axis. Okay, xz plane covers x-axis and z-axis. And what about xy plane? Xy plane will be the plane that has x-axis on it and y-axis on it. Okay, another plane might be yz plane. Okay, the plane that covers axis y and axis z. Okay, but in this scenario, they say the proton moves on the xz plane, and there is the magnetic flux density pointing to the positive z-axis like this, and the intensity or the magnetic flux density is 2 Tesla. The proton move with the speed 3 times 10 to 5. Okay, the speed here is 3 times 10 to 5. The absolute value actually, I should not say equal because it's not vector quantity. Okay, it moves with 3 times 10 to 5 meter per second. Okay, and I need to mention to you that you can use a typical expression in physics when the speed of any particle is not close to 3 times 10 to 8, okay, or the speed of the light. If the particle has a speed which is close to the light, you cannot use a simple formula in physics. You have to deal with relativistic theorem by Albert Einstein. What is that then? Okay, you have to use relativistic speed in this velocity. In this scenario, okay, it depends on the observer, and it involves this factor, okay, the gamma. Okay, if your velocity is very close to c, okay, you can see it's divided by c. You have to use something like this. But in our scenario, the proton particle doesn't have so much speed as close to the speed of the light. Okay, it's not 3 times 10 to 8 or 1 times 10 to 8. No, it's acceptable to use the typical formula in physics. Okay, and we don't need to worry about that. But if you go to any other problems in textbook, several textbook, if the speed of that particle is very close to the speed of the light, you cannot use the simple velocity expression. You need to use the relativistic velocity by Albert Einstein. Okay, but for us in this example, everything is fine. The angle of the motion of that proton is 30 degrees. So if we measure from the positive z-axis, we get the velocity vector for the proton motion like this. Okay, and 30 degree with respect to the positive z-axis, and let the charge of the proton be 1.6 times 10 to negative 19 coulomb. So it's exactly the same amount of the charge by electron, but this is actually the approximation. If you want to see the exact value, if you want to see the exact value of the electron charge, it's somehow it is here. Electric charge is 1.021766634. Okay, if you study physics in bachelor degree, master degree, or you do your PhD doctoral thesis, okay, you use this number. Okay, but for us, we are at the base, at the beginning step in physics. We simply use the simple number like 1.6 because 0.2 has no significant effect to us. Okay, we will throw it away. We will consider only the first digit accuracy 1.6. Okay, the power here should remain the same. Okay, 10 to negative 19. The question to this problem is, what is the force on a proton in this scenario? So I'll find the force, right? So of course, in physics, we need to determine two things, right? In physics quantity, you have to determine two things. The first one is direction. The second one is magnitude, right? Direction could be found from the so-called right-hand rule, or F Q V cross B, right? Or simply speaking, is known as right hand rule, right? And the magnitude could be found from F Q QVB psi theta, right? Okay, this is the scalar function. Direction. Let's talk about the first direction. You rotate your four fingers from V to B. Okay, from V to B, and of course, you will get the time direction, right? And what do you think then? The direction of the induced force should point downward or upward or to the right or to the left or what direction do you think นะครับคุณคิดว่านักเรียนคิดว่า V ไปหา B นะหมุน4 นิ้วนะครับใช้มือขวานะลองจินตนาการนะครับถ้าใครอยู่ที่ Streamlab นะครับที่ผมมีกล้องให้นะผมจะหมุนมือให้นะประมาณนี้นะครับ V มาหา B นะครับที่ซูมก็เห็นหรือเปล่านะครับหมุนมือไปอย่างนี้นะครับ V ไปหา B นะครับก็นิ้วโป้งนะครับก็จะเป็นทิศของ F นะครับเห็นไหมใครอยู่ที่ Streamlab ก็จะเห็นนะครับ V นะครับ V นะ V แบบนี้นะครับแล้วก็หมุนมือนะครับหมุนไป B นะอย่างนี้นะครับแล้วนิ้วโป้งชี้ลงนะครับก็จะเป็นทิศของนิ้วโป้งชี้ลงจะเป็นทิศของ F นะครับ so คุณคิดว่า F ในสถานการณ์นี้ชี้ไปทางใดครับชี้ไปทางแกนบวก y แกนลบ y หรือว่าไปทางบวก x ไปทางลบ x ไปทางบวก z หรือไปทางลบ z หรือชี้ยังไงครับลองตอบดูสักคนนึงครับมีไหมครับตอบไม่ได้เปิดไมค์ไม่ได้ก็พิมพ์มาก็ได้นะครับโอเคมามันไม่เหมือนห้องจริงเนาะมันจะได้ตอบกันง่ายๆนะครับลองคิดดูครับ any idea about that V to B by using the right hand rule from this one okay you may prefer this technique or you may prefer this complicated technique but this one could be easily confused in my idea in my opinion but if you were born like the son of Albert Einstein you may prefer this technique but for me it's quite complicated I prefer this simple technique okay V to B and then you get F direction from the thumb finger okay in this scenario V to B what should the direction of the induced F or the Lawlens Force be นะครับคุณก็จะพบว่าหมุนนิ้ว V มา B นะครับทิศมันก็จะชี้อะไรชี้ลงนะครับโอเคป่ะชี้ลงก็ so our F direction is gonna be point our F direction will point downward okay down like that okay yes we finished the first step in physics direction downward let's talk about the second thing magnitude we're gonna use this expression okay let's remind what is Q of proton right Q a charge of proton is 1.6 times 10 to negative 19 coulomb right and velocity of course our velocity doesn't reach the speed of the light our velocity is not close to the light we can use a typical formula in physics is 3 times 10 to 5 meter per second and after that the third quantity the magnetic flux density is 2 Tesla right and the last one is the angle between V and B it is of course here they provide they have measured to you here is theta angle so theta could be 30 degrees or if you prefer the radian it could be pi by 6 right so let's substitute all of these into the basic formula F Q V B sine theta right yes of course Q will be 1.6 10 to negative 19 coulomb, and V is not high, 3 times 10 to 5 meter per second, and B is the magnetic flux density is 2 Tesla, right? And psi of 30, right? 30 degrees, and what you can feel is that it's actually 1/2, right? Yes, of course, we can put them to the calculator, or you can use your hand. It's no problem. These cancel each other. It's going to be 4.8, right? These will cancel with this one, and you get 4.8 in times 10 to negative 14. Okay. Of course, the result will be in Newton. If you don't believe me, we can use the calculator. Okay. What is that? 1.6 E minus 19 times 3E8. Oh, no, 3E5. And times 2 and times the psi 30 dec, right? 30 degree, and we get 4.8 times 10 to negative 14. E is the letter in computer basis, okay? In computer language, it's equivalent to 10, okay, for us. Okay, we completed the first problem. Is there any question about that? Do you have any question about that? Otherwise, we're gonna go ahead. We still have 40 minutes left. Let's move. Okay, the solution is the answer is the same here. Let's move to the next problem. It's taken from reference number 2, example 19.1. Proton moves ผมเป็นภาษาไทยให้สักหน่อยแล้วกันนะครับสำหรับคนที่ต้องการนะก็เราเรียนกันเรื่องนะครับการใช้กดมือขวานะครับในการหาแรงเหนี่ยวนำของลอเรนซ์นะครับแรงเหนี่ยวนำทางแม่เหล็กนะครับเนื่องจากว่าประจุมันวิ่งในสนามแม่เหล็กนะครับก็จะมีการเหนี่ยวนำทำให้เกิดแรงขึ้นนะครับอันนี้เป็นพื้นฐานจริงๆเลยนะครับโอเคไหมเพราะทุกวันนี้ในชีวิตจริงนะครับเราไม่สามารถเห็นประจุวิ่งผ่านสนามแม่เหล็กได้หรอกแต่ว่าเราต้องรู้แนวคิดเบื้องต้นครับทุกวันนี้เราสัมผัสได้แค่กระแสนะครับก็คือประจุนั่นแหละมันวิ่งภายในขดลวดแล้วมันไปตัดกับสนามแม่เหล็กก่อให้เกิดแรงก็เช่นมอเตอร์ไปขับพัดลมให้มันพัดเราเย็นๆนะครับหรือว่าขับมอเตอร์รถไฟฟ้ารถยนต์นะครับหรือว่าไปขับคอมเพรสเซอร์แอร์อะไรอย่างเงี้ยนั่นคือผลของสิ่งที่เราเรียนกันตรงนี้เนี่ยนะครับก็เราเรียนกันพื้นฐานก่อนนะครับก็คือประจุเม็ดเดียวล้วนๆนะครับวิ่งผ่านสนามแม่เหล็กนะครับแล้วก็สามารถหาได้2อย่างนอกเนื่องจากว่ามันเป็นปริมาณทางฟิสิกส์นะครับแรงเนี่ยมันจะต้องมีทิศทางนะครับ direction นะครับแล้วก็ magnitude ขนาดครับทิศทางนั้นสามารถหาได้จากตาคนนี้นะครับก็คือเฮนริกอันโทนโลเรนซ์เนี่ยนะครับเขาพบว่าให้คุณนำ v ไป cross b นะครับ v cross b เอา v cross b ก็คือกดมือขวานั่นเองครับก็คือคุณมีเริ่มเวกเตอร์ตัวแรกนะ v cross b การ cross ก็คือการหมุนนิ้วนะครับการหมุนข้อนิ้วเนี่ยนะครับเริ่มจากเวกเตอร์ตัวแรกนะครับ v หมุนมาที่ b นะครับแล้วก็ปล่อยขึ้นข้างบนปล่อยธรรมชาตินะห้ามลำไทยดัดนิ้วไปข้างหลังนะครับโอเคไหมใช้มือขวาแล้วหมุนธรรมชาตินะครับกำมือธรรมชาติเนี่ยนะครับแล้วก็นิ้วโป้งก็งัดตรงเดไปก็จะให้แรงทิศของแรงที่เหนี่ยวนำนะครับก็คุณจะพบว่า v และ b เนี่ยมันจะสร้างเป็นระนาบนะครับ v และ b จะสร้างเป็นระนาบ f จะเป็นทิศของแรงครับก็ทิศของแรงนั้นโดยทั่วไปแล้วนะครับมันจะตั้งฉากนะคือหมุน v ไปหา b เนี่ยมันจะได้ระนาบอย่างเช่นนี้ก็จะเป็นระนาบสีน้ำตาลนะครับ F ที่มันเหนี่ยวนำเกิดขึ้นนั้นนะครับมันจะตั้งฉากกับระนาบนะครับคำว่าตั้งฉากก็คือมันจะมีแรงไม่ใช่ดิจะมีมุม90องศาทำกับทุกทิศทุกทางบนระนาบนี้นะครับโอเคไหมF ตรงเนี้ยมันจะตั้งฉากกับระนาบของ v และ b เสมอนะครับนี่คือผลของการ cross ส่วนการบอกอีกปริมาณหนึ่งในฟิสิกส์ก็คือบอกขนาดนะครับนอกจากทราบทิศทางแล้วต้องบอกขนาดได้ขนาดก็หามาจากการ take absolute value นะครับ QB sin theta นะครับแล้วก็คุณก็จับคูณกันไปโอเคไหมจับคูณสิ่งที่สำคัญก็คือควรใช้ absolute value ของ Q แต่ว่าไม่เป็นไรก็ได้ก็ relax เอาก็ได้นะก็คือผ่อนคลายถ้ามันติดลบก็ไม่ต้องเอาค่าลบมาใส่ก็ได้นะครับโอเคไหมหรือคุณจะใส่ลบก็ได้แล้วคุณบอกว่าแรงมันสวนทางกับที่มันควรจะเป็นนะครับเนื่องจากประตูบวกคือควรจะเป็นนะครับโอเคส่วนเซตาก็ไล่ไปเลยเนี่ยไม่ว่าคุณจะเป็นดีกรีหรือว่าเป็นเรเดียนนะครับไล่ตั้งแต่0ถึง360แล้วคุณก็แทนไปเพราะว่าไซน์มันรับได้หมดครับ0ถึง360หรือเกินไปมากกว่านั้นก็ได้นะครับโอเคไหมไปต่อนะครับ let's go to the next example ผมอธิบายภาษาไทยให้ด้วยนะครับA proton moves with the speed 10 to 5, right? Okay, we are happy that it might not be so complicated because it's only 10 to 5 meter per second. It's not 3 times 10 to 8, right? Or something close to 3 times 10 to 8, the speed of the light. In that area, there is the effect from the Earth's magnetic field, which has the value of 55 microtesla. Okay, you know this later, right? It's the micro is the prefix of, you know this one, right? It's micro, and it's equal to somehow tends to -6, right? They say the Earth magnetic field at that location is around 55 microtesla, but don't memorize that. Don't say always that the Earth magnetic field will be only 55 because in nature, the Earth magnetic field will depends on location. For example, they can measure. It depends on the location on Earth where you live, what country you are in. Okay, so magnetic field on Earth might be different. But in this scenario, in this problem, they say 55 microtesla at a particular location. And the next feature is that the next detail of this problem is that the proton moves eastward, and the magnetic force acting on it is direction. Okay, before we go to that, let's talk about eastward. Okay, you no direction, right? This is north. Okay, if you stay here, it's north. This is west, and here is east. Here is south, and you can have the combination of that, like southwest, northwest, and northeast, southeast, or something like that. Okay, but for us, we don't have the combination. We will talk about pure north, east, south, and west in that problem. Okay, we have to draw because this is the physics. Okay, it's not mathematics. We need to express it in out, and here is west, right? It's like you are in the satellite and you look at the map of Thailand. Here you go to Chonburi, here you go to Kanchanaburi, here you go to like Chiang Mai, you go to Songkhla, and so on. Yeah, that's the top view of map, right? They say the proton moves eastward. Let's talk about the 3D version. Cartesian coordinates. All right. You have here the z positive z axis. You have here x axis. You have here y axis. All right. It means your proton, or not electron, it's your proton, right? Your proton move in this way to the east, okay, because east is in direction to the right. Here you are in the satellite and look onto this plane, okay, look down onto this plane, and here is the motion of the proton, okay, and they say that there is the magnetic force that acts on it, and it is directed straight upward. What does that mean? If your eye is over here, how could I write in? No. How could I write the eyes? Okay. Right? Okay. If your eye is here, right, and you look down onto this, you can see that the electron moves to the right, right? And they say the force is given and points upward. Okay, the force will exit and point upward. What does that mean? It means that the force will be directed in this way. So this is the induced force, the Lawlens force. Okay, this is the detail from the problem. And the next step is that they say when it moves northward, oh my god, this is eastward, right? Okay. It means that this problem talks about two scenarios. This is the first scenario, and we would have the second scenario right here. Here is again the x-axis, and here is again the y-axis, and here is the z-axis. Okay, now the proton is not accelerated to the right anymore. Okay, someone changed the proton to move, what they say, northward. Okay, northward means go up, but we look down onto this plane. Proton. Proton should go in this way. Okay, to the north, right? Right? Is that correct? Okay, let's say north is this one, but actually is okay. Yeah, north to this one, for example. Negative x means the north. Okay, no problem. This is the north direction, and what they say is that no magnetic force acts on it. So there is no magnetic force at all in this scenario. Okay, there is no F in this case. Okay, there is no F. It means we have vector F. No, nothing means the vector of 0, right? So the first scenario, we can find the induced force, right? In the second scenario, we don't have any force at all. And given the charge of the proton be 1.6 times 10 to negative 19 coulomb, given the mass of the proton be 1.67 10 to negative 27, but it's not the exact value. Okay, as you know, the proton has the mass like more precision than that. Here the mass of the proton is 1.6726 blah blah blah. Okay, but forget about that. Okay, this is the value once you enter bachelor degree or you do the research in physics. Okay, if you want to receive the Nobel Prize, okay, you will deal with this high precision number. But for us, at the beginning step, we would use the simple digit of the mass of the proton, 1.67 kilogram only. And we laugh at the first question to this problem. What is the direction of the magnetic field actually? Okay, density direction will be constant. Okay, there is no change of the magnetic flux density direction in both scenarios. So what should the magnetic flux density be then in this problem? That's the first question. So what we need to deliver the answer is, the first one is, what is vector B? What is vector B in this scenario? Right. Of course, we could determine the direction of the vector B from the this one, right? We know this one. F is QV cross B, right? But teacher, the left hand side F, we cannot find vector B because B is on the right hand side, and we cannot move everything easily like you want to solve an equation. Q to the left, V to the left, it's very hard to do that, right? And how could we still find the direction of the vector B? Well, let's talk about that. Let's take a look at this. This is the vector V, right? Velocity vector or the motion vector of the particle or proton. In order to get the induced force pointing upward like this, what should vector B be? What should the direction of the vector B be in this scenario? From the right hand rule, of course, you could imagine that if the vector B is in this way, if this is vector B, we can still rotate our V to B, and yet we get the thumb direction pointing upward like this. It is possible, right? Or if the magnetic flux density is pointed in this way, this is still another vector B. It can happen that we rotate our vector V to B and we still get the thumb direction pointing upward like this. So there is no fixed direction for the vector B at all. And if our vector B pointing in this way, this is another vector B. If you rotate your V to B, you can still get the F direction. If all of these vectors, all of these possible directions stay on the XY plane, we can still use, we can still get the induced force pointing upward, okay, for whatever direction of B. So it is very hard to deliver the answer because B can be in any direction on the XY plane. So in order to say give the answer to this problem, it is really hard for the first scenario, right? But in the second scenario, they say that the proton moves in this way. This is velocity vector, but there is no F at all, right? There is no F. So what does that mean? It means that the vector cross product will give you the vector cross product will return 0 to you in the second scenario, right? This. And let's talk about the cross product. What kind of cross product we could get 0 vector? F will be 0, can happen only this one is vector 0, right? If this cross product is vector 0 times anything is going to remain 0. So we fulfill this condition because there is no induced force at all. And let's consider a vector like this. If A is a vector somehow like I minus 3j and plus 7k, and if our B vector B is pointing, vector B is directed in the same direction as vector A. For example, we have 2i minus 6j plus 14k. So what is the cross product between A and B in this scenario? You can see that you're gonna have that determinant, right? And here you have unit vector I, unit vector j, and unit vector k. And now we've laid out the coefficient of the first vector, okay, which is this one here. We will not say I, j, k anymore. We will take only the coefficient. Lay down the coefficient onto the second row. This is the second row. This is the first row, second row, and the third row, right? We will write down the coefficient of vector A, which is number 1 minus 3 and j. And B for the second vector, we're gonna have 2 minus 6 and 14. And after that, let's compute the result from this determinant. Okay, you can see you get unit vector I and minus 3 and then 14. And then you get plus unit vector j times 7 and times 2 and plus unit vector k times 1 times minus 6. And you get minus vector k and 2 and minus 3 and unit vector I. Please note that if you go upright, it's gonna be start with negative sign. The next one is minus 6j, minus 6 and 7 and I, right? So we have I minus 6 and 7, and after that we get 14 1j, right? And minus j and 14 and 1, right? And we get minus 42, right? I and plus 14j and minus 6k. And we get here plus 6k, and here is 42, positive, right? Positive 42 I, and at the end we get negative 14j, negative 14j. And once you combine everything, this one we cancel to this one, this one we cancel to this one, this one we cancel to this. So we get 0i plus 0j plus 0k, and that's, simply speaking, is the 0 vector. So what does that mean? The cross product will return vector 0 to you if those two vectors are pointed or are directed in the same way, in the same direction. So it means, what does that mean? V and B should lay down in the same direction. So what does this mean? We have V in this one, in this direction. The magnetic field, magnetic flux density should be also directed in this way, in the same way as the vector V. So our vector B should be also in this way. Okay, the flux density should be in this one, in this direction. So before that, in the first scenario, we cannot be sure the vector B should be, right? It can be in any direction on the xy plane, but this one is in the same direction as the vector V. So finally we get the answer. What is the V then? V is moving to the north. So the first question will be vector B, right? What is that? This. Okay. Vector B will be B direction, right? The first question, we will deliver the answer as to the north. To the north direction. Okay, to the north direction. Yeah, we will get the direction for the vector B as to the north, because the vector should be in the same way, same direction, so that we get a cross product as 0. The next one is, what is the strength of the magnetic force when the proton moves eastward? The second question is F. What should F be then in this scenario? So F will be พิมพ์เลขที่ผิดครับผิดไม่เป็นไรครับเห็นอยู่ครับที่ YouTube นะครับมีประมาณ 3-4 คนนะครับ Okay, F. What is the F direction in this what is the magnitude of F in this scenario? Here, once the proton moves eastward, right, to the right hand side here. Of course, we know that the magnetic flux density is pointing that way. Okay, now let's write down our configuration. Here is the magnetic flux density vector, and the proton is moving like this, right? Proton, and we have the velocity vector directed here. And of course, once you rotate your 4 fingers, from V to B like this, you're gonna get the induced force pointing upward like this, right? What is the strength? So they just want to know only F, okay, not F with vector, but our F vector is pointing right here, right? From V to B, if you rotate your 4 fingers, you get the time direction as the induced force, right? Induced force will be F here. And what is the angle between vector V and B? Theta, theta between V and B. Of course, this is the north direction, and here is the east direction. If you take a look at this configuration, the angle between north and east is, the angle here is 90 degrees. So it means this figure, this one has also 90 degrees. All right, from V to B, and our theta will be 90 degrees. What is Q then? Q for the proton is 1.6, right? Q is 1.6 times 10 to negative 19 Coulomb, and V is velocity, right? V is 1 times 10 to 5 meter per second, right? Right here. 1 times 10 to 5. Okay, and B okay, let me use another monitor. Chapter 2 605. Right. Okay. No. Okay. V is 1 times 10 to 5. Okay, and after that B is known as 55 micro Tesla, right? And if you convert it, because physics needs everything in SI unit, right? Otherwise we will get something wrong. It means 55 times 10 to negative 6 Tesla, right? B sine theta. Okay, once we know all these four quantities, it's ready for us to compute the F, right? F is Q 1.6 times 10 to negative 19. Q and then V is 1 times 10 to 5 meter per second. And B is 5 times 10 to negative 6 Tesla. And then psi theta, right? Psi theta, which is 90 degrees, or you prefer pi by 2, it's up to you. And once we make the computation, of course, this is only 1, right? And if you make the computation here, it's going to be 8, right? 8 times 10. Negative 1, negative 20, right? And of course, it's equal to 8.8, right? Times 10 to negative 19. The unit for the force is Newton, right? I hope it's correct. 8, 10 to 19. Yes, this one. Okay. Okay. The next question is calculate the gravitational force on the proton when the proton moves eastward. Okay. Calculate the gravitational force on the proton and compare it with the magnetic force. Okay, the magnetic force is somehow it is 8.8 times 10 to negative 19. So we will talk about gravitational force for the proton. The gravitational force will be, of course, mg, right? The weight. This is proton. And there will be W, which is mg, right? The mass of the proton times c, the acceleration on Earth. Okay, let's say mass of the proton is this value, 1.67 times 10 to negative 27. C is 9.8, or you can also use 10, okay, for simplicity at the high school level. Meter per second square, right? And yeah, right now we are ready to make the computation. That shows a little bit complicated, right? 1.67 times E minus 27 times 9.8. We get somehow like that 1.6366 times 10 to negative 26 Newton. Okay, and let's compare. Okay, you can see that the induced force caused by magnetic field is 8.8 10 to negative 19, and the mass due to the gravitational acceleration or the attractive force caused by the core of our Earth is 1.6366 times 10 to negative 26 Newton. Which one is greater than each other? Which quantity is greater than each another? Of course, you don't have to take a look at the scaling factor, or just take a look at the order of the power here. It's 10 to negative 19. Okay, and here is 10 to negative 26. And you can see that this one is greater, so F induced is greater than F gravitational. Okay, F induced is greater than that. The next question is compare it also with the electric force. If there were an electric field with a magnitude equal to 1.5 10 to 2 Newton per Coulomb at that location. Okay, if you have also the electric field somewhere here, and we can find a force, right? It's Coulomb force actually in the fourth problem. Yeah, compare, right? Comparison. And now let's take a look at the where. Oh my God, no. Okay, compare it also with the electric force. F is the fourth problem. We apply the formula F equal to QE, I think. But this electric field is Q, of course, we know Q is 1.67, right? 1.602, right? Times the, what is the chart then? The chart is in the order of negative 19 Coulomb, right? And E, the electric field, is known as 1.5 times 10 to 2 Newton per Coulomb. Okay, once you substitute these two things into the original expression, F will be Q, right, which is 1.6 times 10 negative 19 Coulomb, and E 1.5 times 10 to 2 Newton per Coulomb, and you will get the result later, right? Which is the product between these 1.5, 2.4, I think. Yes, 2.4 times 10 to negative 17, and it's in Newton. So what do you think then? Which one is greater than each other? Again, let's check. Mass of the proton. Okay. 8.810 to 8.810 to negative 19. Yes, all right, it's correct. And F equal to QE is 10 to negative 2. Oh my God, no. Top 9.8, right? Why they have okay, yeah. Yes, it's correct here. The force caused by the electric field is 2.4 times 10 to negative 17. Okay. I think the time is over right now, right? I need to complete or finish our lecture at the moment, and but there's still some more. There are still some more problems. Okay. The homework for today will be any problem related to the Lawlens Force. Lawlens Force. Okay, I'm gonna create it for you in Google Classroom. You just find the direction by using the right-hand rule, or you find the magnitude F Q B sine theta. Okay, it works all fine. Okay, หมดเวลาแล้วนะครับก็คงต้องจบการบรรยายไว้เพียงเท่านี้นะครับการบ้านหมดไปแล้วนะครับคนไหนไม่ได้พิมพ์ชื่อนะครับโปรดพิมพ์ชื่อนะครับYouTube ก็ได้นะครับที่ Zoom ก็ได้นะครับทางไหนก็ได้ที่คุณนั่งฟังครับโอเคif you have any question just let me know ไม่เข้าใจตรงไหนนะครับถามนะครับถ้าไม่มีคำถามนะครับก็จะต้องบอกว่าพบกันวันพุธหน้านะครับอย่าลืมส่งกันบ้านนะครับพิมพ์ชื่อด้วยนะครับlet me see you in Zoom if there is no further any question right then we're gonna leave our we will stop our lecture right now ครับก็สวัสดีครับบ๊ายบายครับ let me see you what you are typing here in Zoom. Okay, ธนกร here so channel right here click into why don't have pressure so soon support volume volume quit okay fine quit and then pimp pick up right there and one, two.